Hi everyone, it's Mr. Hamilton here, and today we're going to look at the relationship among angles in quadrilaterals. So it's 7.2 in your academic textbook, slightly different section in the applied textbook, but it says in your unit outline. A quadrilateral is any four-sided object. The reason we call it a quad is because it has four. So it's a four-sided object. And we can draw a quadrilateral with the four sides as shown, and then all these angles here, angles F or E, F, G, and H, those are called exterior angles. So the sum of those exterior angles is 360 degrees. And if you remember from yesterday, the sum of the exterior angles of a triangle was also 360 degrees. So interestingly enough, the sum of the exterior angles hasn't changed when we've added an extra side. However, the sum of the interior angles has changed. So these angles A, B, C, and D, if we add those together, instead of 180 degrees as they were in the triangle, now we have them adding to 360 degrees in the quadrilateral. So really simple with the quadrilateral, the exterior angles add to 360 and the interior angles add to 360. Let's look at a couple properties beyond that. A parallelogram is a quadrilateral with two pairs of parallel line segments. Probably remember this from past math courses. We have not only that they have two parallel sides, but they also have opposite sides that are equal in length. And so you can see here that I've drawn it with this side here being equal in length to this side, and this side being equal in length to this side. But it also is parallel like this. So this is those two sides that I just drew are parallel, and this side here is parallel to this side. So let's think about what that means as far as angles. If you see the word adjacent, what that means is it means beside. If you are adjacent to someone, you are sitting beside them. Similarly, with angles, we could talk about adjacent angles. Adjacent angles are supplementary. That means they add to 180 degrees. That means that A and B would add to 180. A and D would add to 180. D and C would add to 180. And C and B would add to 180. Angles at opposite vertices are equal. That's the other property here of a parallelogram, is that A is equal to C. These two are equal. Likewise, this here, D, is going to be equal to B. So remember that. Adjacent angles are supplementary. They add to 180. And opposite angles are angles at the opposite vertex are equal. Let's talk about one more property here. Yesterday we noted a transversal is a line that crosses two parallel lines. So this is a transversal in that diagram there. What that does is it has a whole bunch of properties. We talked about the F pattern, we talked about the Z pattern, and we also have this co-interior idea, where if I have two angles as such, these two angles add to 180 degrees. They are supplementary. Any two angles that add to 180 degrees are supplementary. You can add that there. So those two angles are equal to 180 degrees, and if I just draw a different one here, draw this one, we could also say this one and this one, call that A and B, those would also add to 180 degrees. So the transversal is a line that intersects two parallel lines, and that gives us the F pattern and Z pattern as we looked at yesterday, and then just as a review, the co-interior angles that are supplementary as well. So that should help you with the work that you have to do for today. That's really all there is to it, just a few properties of quadrilaterals. Make sure that you're starting with rearranging an equation, laying out an equation and rearranging it. Don't just state your answer. I'll do one example before this video is done. So the example here says determine the measure of each unknown angle. It's a quadrilateral. So the first thing we need to note for a quadrilateral is that all the interior angles add to 360 and the exterior angles add to 360. So we know that A plus B plus C plus D is 360. Those are the interior angles. And the exterior angles are E plus 50 plus 75 plus 115. All of those together also add to 360 degrees. And so with that information, we can say, well, what can I start with solving? Well, we can actually start with solving everything but D. Because we can see in this equation here that E is the only thing we don't know. And you can see that for A, B, and C, we know that these two angles are supplementary. These two angles are supplementary. These two angles are supplementary. So 180 minus the exterior angle gets me what each of those angles are. And then once I know what E is, or once I know what A, B, and C are, I can solve for D. So what I'm going to start with, I'm going to start by solving for each of the A, B, and C. So we know A is equal to 180 minus 115. That gives you an angle of 65 degrees. Right? That's the supplementary principle. The other thing we know is that B is going to be then 180 minus 75 for the same reason. So it's 105 degrees for B. And we know that C is 180 minus 50, which is 130 degrees. So now we've solved for A, B, and C. Now notice we can't solve for D because we don't know what this angle out here is yet. So the next thing I want to do is solve for E. And I've got the equation here. Rearranging that, I get it's 360 degrees minus all the other angles. So minus 50, minus 75, minus 115 degrees. And I get angle E is an angle of 120 degrees. Now at this point I can go, well, angle D then is going to be equal to 180 minus E, 180 minus 120, and we've solved for that to be 60 degrees. And so now we've solved for all of those angles. So I just want to remind you, if you're in the academic class, sometimes you're not going to just have a letter to represent an angle. Sometimes you'll have letters representing the vertices. And if that's the case, you're going to want to watch for that. So for example, I could label this as A, if I label it as capitals here, I could label it as A, B, C, and D are my vertices. And then I could label these other pieces as E, F, G out here, and then H out here. And I just want to remind you that if you aren't given the letters, a single letter for those, you have to name it with 3 letters. And so in terms of the diagram that we have, the other way to label angle A is to label it angle BAD, according to those capital letters. The other way to label angle B, small b, is to label it ABC. You could have also labeled it EBC. That's fine as well, just so long as you're picking the middle letter is where the vertex is, and then the other 2 letters are representing the line that goes out from that vertex. For C, go ahead and try to solve that yourself. Pause the video and check it with me and see if you got the same thing. I said angle BCD, or angle FCD would work as well. For angle E, that would be CDH, angle CDH. And then for the last one, you should be able to, for D, get ADC or ADG. ADC or ADG. So just want to remind you how to label those angles with 3 letters if you're not given a letter for, or a variable for that angle. So there you go, guys. That's our video for today. That's our lesson for today. Go ahead and solve some properties of quadrilaterals.